Thank you all for continuing to stick around. We've got some awesome presentations this afternoon. For after lunch here, I want to introduce Paul and Mark. Paul is from Micron and Mark is from Toshiba. And they will be presenting verifying SSD sanitation. Should be a really riveting conversation that we're going to have here right after lunch. So let's go ahead and get started. All right.
Okay. Thanks. Mark and I are going to kind of tag team this. Anyway, so there I was sitting quietly at my desk, getting some work done, and I heard this, I'll say, exasperated sound from Mike Danielson, my boss who sits near me. And he called me over and he showed me an email we'd gotten from what you'll see later in this I refer to as a naive customer wanting to know how we could prove that his drive was sanitized. So we started talking about this and we decided we needed to direct people in a different direction. So what we're going to do today is tell you what sanitization is. In fact, how many people in this room are not familiar with the NVMe sanitize command? I want to not familiar. 1, 2, 3. Okay, well, we're going to cover it kind of briefly then. Then we're going to talk about some of the problems that the customers and vendors can encounter and then propose a new way. So, Mark?
Yeah, we're not really going to challenge you technically so much, so you could take a nap if you wanted to, I guess. But why sanitize SSDs? Well, there's issues when drives get returned, when they get repurposed, or even just, quote, throwing them away. How do you know that your data, and your data might be critical, is not still on those drives somewhere? And accessible via the host interface is one thing, but accessible via taking it apart and looking in the NAND chips is yet another way. And manufacturers have been exposed when some of that does take place and they find out you had a bug in your software or something, right? And so there's sanitize commands, not just for NVMe, of course, but ATA and SCSI. And they're all designed to, as far as SSDs are concerned, to erase all accessible storage, both accessible to the host and accessible to the internal firmware of the drive itself as well. So then when your SSD is ready to move on, your sanitize is keeping your secrets secret.
And it better. 15 years ago, the Lab for Computer Science at MIT did a study of 158 drives, and these weren't only SSDs. They found something like 5,000 credit card numbers. They found personal financial data, corporate financial data, medical records, personal email, and pornography. So people many times have not thought about this. Okay, but to move on, I said we'd tell you what sanitize actually is. So this is oriented toward NVMe in particular. There are two distinct things. First is the sanitize command that begins the sanitize operation. The intent is that sanitize operation is going to affect any allocatable media in the entire NVM subsystem. There are 3 different types of this, and we're not going to go into all the details on this. One is a crypto erase that applies for what are called self-encrypting drives, where you can simply change the media encryption key and the data should be inaccessible or ununderstandable. There's the overwrite, which is kind of what it says it is. You overwrite that data, which is problematic in terms of SSDs because they don't work like disk drives do. And then there's the block erase. The general concept is that when the sanitize operation begins, the drive will start returning errors on any attempts to read or write data until the operation is finished, until the drive's thoroughly sanitized. The idea is to let nothing interfere with the operation and let no data be pulled out in the interim. So what happens if there's a power cycle? Well, sanitize is a kind of unique operation in that when the drive powers back up, if it was in the middle of a sanitize, it'll keep going. So the sanitize mechanism through these 3 different standards has been defined in a way to try to keep it from being hacked by a simple thing like a power cycle. So there are actually a couple of variations, and I'm not going to dive into the details. The original version is keep the device blocked if the sanitize operation fails. And there was a more recent version of sanitize, and this is set when the command is first processed. It can allow unblocking the drive if the sanitize operation fails. So, of course, the host software has to know exactly which version it's doing. Now, the status of a sanitize operation is that it can be reported through the sanitize status log page, which will tell you what was done and did it succeed. Now, you may have heard of secure erase. Those are some options inside the format NVM command. And those are certainly important to security, but that's a different talk. We're not going to talk about that. So I'll let Mark tell you about why simply sanitizing a drive can be a little complicated.
Well, again, it's not complicated technically. It's complicated because SSDs are kind of funky in how they write your data. And they may have written some of your data and then removed it from accessibility by the host. So, what you can see through that host interface of your data is not the entire set of data that you want to erase. SSDs have been doing this forever. It's everybody's magic sauce how they do it. But customers at this point still don't trust us, the drive manufacturers, to actually do the right thing when it comes to that data that's been written. It may be a bad block we took out of the pool totally. How can you erase data on a piece of NAND that can't be written to anymore? This is one of the questions they have all the time. So, if they can't trust us to do a sanitize, they go into the shredder. And there's lots of customers that is just the default position. With sanitize or not, the drives just go into a shredder before they can leave the data center.
And some of the problems with shredders that apparently even now some silicon, when it's broken into small parts, will damage the shredder. But that's beyond what we're going to talk about today. Okay, so I mentioned naive customers. Essentially they're asking the drive, prove that my data has been sanitized. We're going to contend that's the wrong question. But what does sanitize do? Okay, so as Mark was saying, a sanitize operation is going to alter all of the data in the NVM subsystem, whether or not it's immediately accessible. It may have been deallocated, etc. Caches have to be cleared, and all the non-volatile media, of course. The controller memory buffer that you heard about earlier today can certainly have user data sitting in buffers. That also, by the current definition of sanitize, we've already covered that. We've covered that in the standard. That has to be cleared. So the main points here are that the status is sent back over the interface. We're making a promise over the interface. Like I said, we touch all the allocatable memory. Sometimes some implementations will leave the memory not accessible and deallocated. Others will allow it to remain readable. Bad blocks, those also have to be sanitized. And the problem is that the checks run after sanitization, by a host can only check what's done through the interface.
So can you trust us as drive manufacturers? Can you trust the drive at its word that sanitize completed correctly and that your data cannot be recovered from the drive via any means possible, right? Well, yes, most of the time, unless you get in and hack the firmware, like some three-letter agencies have done. If you do let the key out of the drive on a self-encrypting drive, just deleting the drive's version of that key is obviously not going to protect you from somebody reading that data, that ciphertext back and decrypting it. So what's the guy to do?
So we have less naive customers, and they will do things like, well, we want to do a code review with you. Why don't you walk me through your sanitization firmware and make sure that it's doing, it does everything I think is right. Well, for years, people tried to do proofs of correctness for programs. And the bottom line, bright people like Edsger Dijkstra have worked on this for many years. The problem is that formal proofs of correctness don't work for very sophisticated or complex programs. Ultimately, you can't prove that there is no bug in the system. You test and test and test, but you're never totally sure. And Curtis Stevens there advised me not to say that because they'll say, oh, well, that's only Micron drives. But we all know better. Okay. Also, as Mark said, there is an NSA tool set that was found to hack storage devices. Testing, reading the data back doesn't prove that that the drive wasn't hacked. Also, from the point of view of a drive vendor, now I've got to walk with every customer through my intellectual property, and that's something that kind of makes us nervous. NDAs to the contrary. So what's done? Well, in terms of going through the interface, you can do spot checks, random LBA reads, and there are suggested rules and different standards for that. Or possibly do an exhausted LBA read through the entire space that's accessible, and do enough reads that you can writes and then reads that hopefully you cycle through reallocated storage, use the over provisioning, and hopefully the amount that you have tested will be enough to ensure that there is statistically a very good chance that you have caught everything. So we have another idea.
So, as Paul mentioned, the other processes that we've looked at just don't scale. If you have to talk to every customer and convince them that your drive works as designed, you're going to spend a lot of time holding a lot of customers' hands. Hopefully, you have a lot of customers. So, what about third-party verification? Right? Can we just send drives to maybe one or two certification houses, and they do what the customer needs to have happen for their own trust to be established, right? So there's a couple companies. On Track is one, Drive Savers is another, and if this does take off as a great idea for people to do, then we'd like to standardize the testing procedures through NIST or some other organization so that there could be a better ecosystem around these third-party testing certification of sanitized implementations.
So what do these third parties actually do? Well, there are standards that give guidance. Typically, a drive vendor will submit multiple copies of a drive with, the specified firmware, and these will be tested. The tester will write known data across the drive. They'll perform the sanitization as specified by the manufacturer, and then ideally in a way that doesn't do deallocation. And then they go back through and examine addressable blocks through the interface and confirm that the original data that was there is no longer present, or at least cannot be read, and there's an important difference there. Now, deeper testing, which as I've been investigating over the last couple of weeks, turns out to be much more popular, is that the testing organization will demount all of the NAND die, resolder them onto test jigs, and then go in and do raw reads. And then the tester will certify that the SSD with that firmware will meet their process for testing according to the standard. But again, these are in some sense private label certifications because, what one house does may be somewhat different from what the others do.
Right. And maybe there's no real value to keep one-ing up each other as far as, well, we do an even deeper test than our competitors do. So if they're going to pull these things apart, they're going to need help talking to our raw NAND devices. As those of us that make both NAND and SSD can tell you, each generation of NAND is going to be slightly different, and how you write to it, read to it, and so forth. So if you really want to understand whether you're getting back true data, you're going to have to work with the manufacturer of the NAND as well as the SSD in order to make that happen. So if you're identifying some blocks that aren't supposed to be changed, if you're testing to make sure that the code came directly from the manufacturer and not somebody slipped in a different version of firmware in there, those are all approaches that would be documented in some sort of you just advanced way advanced.
There.
Yeah. Okay. I pretty much done with it.
Oh, okay. Great. So there are a number of technical issues. We don't need to dive into those right now. They're in the presentation. So this is the direction we think we should go. Like I said, up till now, we've had a couple of testing houses doing their own testing to their own processes. What we think we should do is get NIST, National Institute of Science and Technology, to establish a new FIPS certification program that would cover sanitization of SSDs. By the way, people often use the word FIPS testing as shorthand. What they're really in our world referring to as FIPS 140-2, the cryptographic module validation program. But actually FIPS means Federal Information Processing Standards, and there are a lot of those besides 140-2 or -3. Anyway, so our idea is that if a drive complies with a FIPS would be more compelling, carry more weight than a certification done to a private company's standard, even if the ultimate target is some specified guidance that comes from NIST, like in SP 800-88 on what should be done for sanitization. Now, this program that we're trying to kick off would include both testing, probably both testing and a design review, but it wouldn't be as broad as the 140 testing. It doesn't need to be that. And we think that we could get this done faster if we do a new small FIPS rather than try to tag it on to the next version of 140-2. So that's why we are aiming at a sort of standalone certification.
So the ultimate customers are going to, majorly be the three-letter agencies, right? DIA, CIA, NSA, FBI. The guys that have data that they don't want to lose, or they do want to lose in some cases. So I think part of what we need to do is get those customers excited about some sort of program like this, to put all their differing requirements together into a single set of requirements that the certification could meet. And then those folks will obviously feed that into NIST, which is also another four-letter government agency that are the folks that everybody pays attention to when they come out with a new version of this spec. So I think we're scheduled for like a 20-minute 10, and Lance keeps lowering it.
All Lance.
A Flash Memory Summit sort of mini BOF, where we can hopefully get some folks, some real customers in, and talk about this a little bit more for a very brief period of time.
And so where do we stand right now? I've started conversations and keeping all these the people involved in this talk in the loop with Drive Savers and OnTrack, who are very supportive of the idea. And I'm trying to open up a path through Micron's test lab to NIST to get them involved and try to see if they're interested. We'll see how that goes, and I'll give you an update in August. Thanks to a couple other people, John Tangay at Micron and Mike Danielson, my boss. And again, I'll mention John Geldman, who we had wanted to have here, but for some reason he felt it was more important to be with his family at this time. So in Puerto Rico. So what can you say? By the way, here's some references that give guidance. There are others, but I'll give you a further update in August. Okay, question, Judy.
Yeah, so
What?
Judy and Mike.
There.
can you hear me?
Yeah, okay.
If you got all the government agencies to work together, I can't say that with a straight face, but anyway, if that happens, if that were to happen and the testing moved into a governmental agency, but as you pointed out, it takes expertise from both the NAND companies and the SSD companies. You're talking about all of us drive vendors handing over all the specifics of our secret sauce for NAND and SSDs to the government?
No,
Or am I
No,
missing
it's
something?
third parties.
Yeah.
Under
But you
NDA,
said the
by the
NIST program and the FIPS programs were governmental
So
oversight.
on-track and drive savers, right, are the ones that certify you to the government standard. Okay? You work with on-track and drive savers under NDA,
Oh, okay.
right? So that your secret sauce can be verified,
Okay.
but nobody else has to see it.
Got it.
Okay?
And
Thank
the
you.
explanation I got is, yes, we can even do this without help from the drive vendor. We know enough about how SSDs work, but it goes faster if we have assistance from the drive vendors.
So they don't have to reverse engineer.
Right. It speeds up. Yeah. David?
Sure. First of all, want to generally encourage this direction because I think I see out there an over-reliance on FIPS 140. In an SED, FIPS 140 is assurance that the crypto is right. It provides you no assurance that crypto erase actually erases anything. For example, and there's lots of people who say, okay, FIPS 140, I want to see that because it's the only thing out there for security. So general supportiveness. Making an independent program is fine. Please consider whether FIPS 140 certification granted or in progress is an entry criteria for the program. Don't want to go certifying a secure erase with bad crypto. And I think let's see, and I think that'll do for now. I may have more to talk to you guys about in private.
Okay, thanks. Let's see. We got.
We weren't looking at extending FIPS to cover this, maybe pointing to FIP, the existing one.
Right, you're right. Crypto erase would rely on that. Okay, go ahead.
So you didn't say anything about metadata. Presumably metadata does not get erased during a sanitize.
Oh, yes. Yeah, that's specified. Check out the description of the sanitize command in NVMe 1.3. Yeah. So, yes. Because you could obviously use protection information if it weren't cleared as a way to try to infer something about the data that was there before.
So
hang on. Okay, Tom, you're next.
yes. And you mentioned it before also in the talk, but the crypto erase, and oftentimes I've heard that's really the only way you can make sure that the data is going to be inaccessible. Do you still believe that's true? I know Micron, you guys have a way that you can actually erase some of the older cells, that kind of thing. But can you get beyond crypto erase and effectively know that you made the data inaccessible with an SSD?
That's a good question, and I'm technically not part of the security team at Micron, so I can't answer directly. Mark, can you say anything from your side?
You're talking about a hardware assist of some sort in the actual chip?
No, crypto erase.
Crypto erase.
Yeah, where you've got, you have like trusted computing group sort of
right. You have a root of trust inside the drive.
Right, and then you erase the key and suppose that you
Correct.
can't read the data because it's all cryptex.
Correct.
Yeah.
Is there anything more effective for actually erasing the data in all of the SSD than that would
make
be?
it everything in erase block erased. That's more effective at a physical level, but there's nothing faster than crypto erase, obviously.
Hang on, Curtis. And one way we might approach this is for the people like Drive Savers and OnTrack and whoever else wants to get involved come in with as much of their test process as they would like to expose, and we'll stack up all these different ways of approaching this and then start sorting them into different levels of assurance, maybe just two, and build up something that NIST can use as the starting point for a new FIPS.
Customer requirements.
And customer requirements. We expect to have not just the test houses, but also customers and system vendors. So, system vendor, yes.
Well, system vendor and storage device vendor. So, as those of us who've done devices that passed FIPS 140-2 know, FIPS is hard to pass, takes a long time, it's on a specific version of firmware, and it doesn't find everything. Yep. So frequently what we end up with is a FIPS certified version of firmware that is known to be insecure by the time it's released, and the most secure version of the product is actually the one or two or three revs down that have fixed that firmware bug. Yep. Have you thought about how to deal with that type of problem with this process? Having participated from another company in HP's certification, we did joint development on tape drives for a few years.
The best that NIST has been able to offer is a test of the incremental changes, and depending how big those changes were from the certified firmware to the new bug fix firmware, that will vary the length of the process. I'm open to suggestions as to how they could possibly be sped up, but you basically have to certify, the hardware and a version of firmware. Otherwise, it's meaningless. Yeah, Peter.
So I may have not be remembering this correctly, but I thought when we were doing sanitize, we said that the data was not accessible to the host. So in other words, if there was a failure, but it was still not accessible to the host, that would be okay.
Right.
So peeling NAND devices off the board or coming in through, manufacturing interfaces that are not generally accessible would seem to be different than the sanitize that we've been talking about.
Well, may I?
Let me speak first.
Okay, go ahead.
All right. So the sanitize that we talked about is what is available through the host interface, right? And when you do a sanitize, there's a no deallocate, right? That says, yeah, you can come in and investigate all of the areas that are visible to the host. But we're also promising that we're going to take care of the areas that aren't visible to the host, and it doesn't matter whether they're allocated or not, right? Right? So this is going a little bit further than that, and we're not advocating changing the NVMe interface in order to do so. Right? We're saying, again, it's not technical talk, it's not a proposal for a new feature. It's a way for us to scale this sort of trust that we need to develop in order for the feature to even get adopted. Right? Sure. Kevin has a follow-up, and then
I still think
Paul has a follow-up.
And that's why I asked David earlier, but I still think the way the NVMe spec is written and the ATA spec and the SCSI spec are written, they take it from the perspective of the host.
Yeah.
Now, I certainly agree with you that the way it's written, it says, I don't care what's mapped to the host, you got to blow away all that data. In the possibility that that block may be remapped through the FTL, or whoever hell wants to do it, to the host. But to Peter's point, when you're desoldering crap and putting it on a test bed, that was never really the goal of sanitize.
I agree.
In that, you're going to have a dead cell you can't erase. It's there forever, right?
Correct.
Shredder. I mean.
But okay. If you look at, say, SP 800-88, I believe, which is really guidance, it's not a test program. What it says, I believe the terminology is you want to make sure the data is not going to be accessible to I think the term is state-of-the-art lab. So they would like to see essentially protection against, an attacker who gets hold of a discarded drive and then proceeds to desolder all the NAND.
I think in that spec, and you guys have much more expertise, but there's like 3 levels. There's like purge, destroy, and I forget what the first one is. Seems to be the one that the NVMe sanitize was written to. But that doesn't mean that especially government agencies are going to find that to be sufficient.
Yeah.
And that's the problem.
Now, we had another, yes.
Yeah, so I was curious when you mentioned three-letter named government agencies and how we all know how they destroy their hard drives. I was wondering, wouldn't they prefer to just melt away these drives and do it 3 times?
Yes, and if
Rather than-
if your requirements are that high, then you're not going to care what we certify here. So yes, there are a few people like that, but a lot of our customers are not willing to throw away their drives as soon as they've been used by the first customer. Do we have another question back here?
Yeah, so I'm getting spam from GDPR all over my inbox from various companies, including such technically savvy places as Etsy. If I'm a drive consumer, is there something in our process that's certified to those sort of levels of requirements?
I'm sorry, I'm not quite talking. All right, go ahead.
It's the new EU requirement for privacy that goes into effect
GDPR is a new
next month.
EU privacy standard. And this does not address that. Now, it can be used as a building block by service providers to further ensure that private information is not sitting on that drive when it leaves the data center. Does that make sense?
We have time for one more question.
One last question. Right there.
Have you heard of a thing called physically unclonable function, PUF?
I have not.
No.
Well, see, you have something to look up now. PUF is a physically unclonable function that is absolutely part of the device, and you can't, it's not easily lifted no matter what you do. And there's devices are being developed because this provides you with the one-to-one and onto part of the encryption sequence. And I was always wondering what you guys would do in an overrun situation, because we always had that problem in the cruise missile. And that was an interesting problem as it worked out.
Yeah.
Works out a microwave oven, industrial microwave oven does a really good job.
Thank you for that pointer. And we'll wrap up now, and Janine will introduce the next folks. Thank you.